The lesson today will be on normal distribution. Now, let's have a look at what normal distribution is. If we actually plot a set of data in terms of histogram and we join the top of the histogram, and if the data is actually normally distributed, it actually forms a bell-shaped curve. Now, the mean is right at the center, and the bell-shaped curve is actually the form of a distribution, normal distribution. It is also known as the Gaussian distribution. In this case, the mean is the same as the mode, as the same as the median, right? So it is actually right in the middle of the distribution and is symmetrical about the center. 50% of the data value is less than the mean, and 50% is actually greater than the mean. So let's repeat again. The normal distribution, the mean is the same as the median as the mode. It is always symmetrical about the center, and 50% of the data is less than the mean, and 50% is greater than the mean. If you look at the normal distribution curve, it could actually be measure of, say, a height of a students in a particular year group, or maybe the length of a baby when they were born in a particular month. But what is the relevant to you? Maybe we'll think about it as the marks. The mark of the exam, or perhaps ETA. Now, if we actually take this as the mean, right? The mean mark is, say, 50%. Around this area, on both sides of the mean, okay, that is what your student will score C, right? And then a little bit higher, this is your B, and this is your D. And a bit higher again, this is your A student, this is your E. And of course, the rest is either A plus or F. So, for a perfectly distributed score, you've got a range of students who scores around C, B and D, A and E, A plus and F. What does it all mean? Now, this is actually the 68% rule. 68%, 95%, and the 99.7% rule. This bit of the curve here, which is where your student actually scores C, that is the mean plus one standard deviation. And the area underneath the normal distribution curve is 68% of the curve. B and D, the area under the curve, which includes C, is actually 95%. And you've got your A and E, the area under the curve is 99.7%. Alright, or we can summarize it this way. 68.3% of data values are within one standard deviation of the mean. 95% of data values are within two standard deviations of the mean. And 99.7% of data values are within three standard deviations of the mean. Back to here again, this bit here, 68% of the area. Here, 95% or 94.5% of the area, and that bit here is 99.7% of the area. Now, pause the video for a while and actually write this down. To have a look at an example. Let's have a look at this example. A box of breakfast cereal has contained 500 grams of breakfast cereal printed on it. Suppose that in fact the weight of breakfast cereal contained in these boxes is normally distributed. Now, normally distributed with a mean of 512 grams and a standard deviation of 8 grams. Determine the probability that the randomly chosen box of this cereal contains between 504 grams and 520 grams. Let's actually plot this information in this graph. All right, we know the mean is 512 grams, or we can put it this way, down here, 512. That's the mean. One standard deviation is 8 grams. So 512 plus 8, that is 520 grams. And one standard deviation below that is 512 minus 8, which is 504 grams. If we want to extend it a bit more, 512 plus 2 standard deviation, which is around here, 528, because it's 8 times 2, which is 16, one standard deviation, another standard deviation. So it's 512 plus 16 gives us 528, or 520 plus one more standard deviation, which will give us 528. Now in this case, 2 standard deviation is 504 minus 8, or 512 minus 16. So 504 minus 8, that gives us 496. And last but not the least, let's have a look at 3 standard deviation. 528 plus 8, 536 grams. And here is 488 grams. Now, we know that area under the curve between that is actually 68.3% or 68%, the 68%, 95% and 99.7% rule. Area under this is actually 95.4%, not 99.5, it's 95.4%, and area under this is 99.7%. Therefore, the probability of the cereal contained between 504 and 528 grams is area under this graph, which is 68.3%. If you ask another question, what is the probability of the cereal contains between 496 and 538 grams, is actually between this line, which is 95.4% or 95%. Let's have a look at example 2. A box of breakfast cereal contains 500 grams of breakfast cereal printed on it. Same example, as you can tell. Suppose that in fact the weight of breakfast cereals contained in these boxes is normally distributed with a mean of 512 grams and a standard deviation of 8 grams. Determine the probability that a randomly chosen box of this cereal contain less than 500 grams. Now, in the random sample of 100 boxes of this cereal, approximately how many boxes we would expect to contain less than 500 grams? Okay, let's have a look at the normal distribution curve again. This time, I have generated it using a nicer diagram rather than my hand plot. So this is actually the mean. We are looking at the area, which is 500 grams and under. We know that mean is 512 grams and standard deviation, or actually sigma, is 8 grams. How do we actually look up the area of the graph? Let's actually use your calculator to do it. Grab your class pad and let's start looking at how to use it. Alright, let's have a look at how to use class pad. You can use the normal distribution function either through main or statistics. So that you can remember, normal distribution is always linked to statistics. We will actually go via statistics button. This time, go to calc, under distribution. What we need is normal CD. Go to next. Determine the lower and upper limit. The lower limit in this case is minus infinity and the upper limit is 500 grams. Because we know that we want to find the probability of the box lower than 500 grams. So under upper, we type in 500, and lower is minus infinity sign is in maths 2, right under your keyboard. Sigma is the standard deviation, which is 8 grams, and mu, the sign, the symbol here is called mu, and it's actually the mean, so it's 512 grams. Now, if you click next, the probability is calculated. In this case, the probability of the box less than 500 grams is 0.0668072. From the calculator, we actually know that the area or the probability is 0.0668 or approximately 0.07 or 7%. Therefore, if you're going to answer the question 2 in the random sample of 100 boxes of this cereal, approximately how many boxes should we expect to contain 500 grams? So it's actually 7% times 100, which is 7 boxes. Right. Now, just recapping, to find the probability of anything below certain amount, you actually have to find the area using your calculator. In this case, using your calculator, you actually found that the probability is 7%. And using that information, we can expect 7 boxes to be contained less than 500 grams. Right. Now, let's take it a little bit further. We looked at the normal distribution. Remember, previous lesson we actually learned standardization, which is this formula here. Standardized score is the raw score minus mean divided by the standard deviation. Now, we can standardize the data into the standard normal distribution, where the mean is actually 0, 1 standard deviation is 1, 2 standard deviation is 2, and 3 standard deviation is 3. The reason why we do this previously is we don't have calculator, and to calculate area under any normal distribution, it is easier to standardize it and use a standard normal distribution. Nowadays, with the calculator, you can just input it as a mean and the standard deviation, and the area can be calculated. However, bear in mind that there will be examples that you need to use the standard normal distribution. Let's have a look at the notation. This is actually the notation used where X is normally distributed set of data, and mu is the mean of the data, and sigma is standard deviation. Please write this down. Alright, this is the end of the lesson.